Okay, so we've been working on the PCIe, and then of course, you know PCIe and CXL would be the same fabric manager's idea. So we are working on the CXL now. And today, topics that we will go is 3 different topics. We have a real systems, real one, based on SCON system. Then we will talk about the software features and the API that we provide, how people to use it, how people to manage it. I go through this very quickly. We just do the memory pooling appliance, and that is appliance is of course in one of the rack and being connected through CXL, and when composed, it will be look like from application point of view or OS point of view, it looks like their own memory, right? So we do the memory pooling appliance and the fabric management software. This is a real one. The worldwide is a real one. This we based on the SCON 256 CXL switch to build up this. So there is a switch to connect to the host and also the CXL memory modules. And then there's a one MCPU. The MCPU have the fabric managers. They can do the memory mapping to the host. And all these CDIP connectors are connected to the either host or memory module chassis. This is the first units. In fact, we are not just have one, we have 2. The second one is this one is another one. This one is put everything in the box. The previous one is a more flexible one. So more flexible one means that you can have your how many hosts you want, how many memory module you want. You can flexible to adjust it. This one also can adjust it, and this one that he provide the 15 PCI CAN slot. That CAN slot can put either 6 of memory modules or host adapter. And then of course there's also one MCPU to manage which one belong to which one. And because it's 2 ways, you can put front access or back access to use different cables direction that you want to use a front access or back access. It's better for the different data center want to deploy this. The dimension is a 2U, and of course 19-inch wide, right? And it's around 890 millimeters. It could be fit into the 1 meters rack. And of course you see it's either to the host side or to the to put the memory. So you can have 2 different ways to use it for your cooling and your host connections. These are software architectures. In the light blue ones, we have collect all the information from the CXL switch and manage the port configurations, memory mapping, that kind of things. And of course, we also collect the information from memory modules and present it to the through the API and or GUI or go to the orchestrations. Not just that, we also collect some management information. For example, like each single port's ingress and the egress performance through a period of time. Then it's easier for you that to decide. For example, like members want to see which memories have a big capacity, have a less utilization rate. He will choose which memory he wants to be allocated to one of the hosts or to be a shared memory to get the best performance of that. So that is what we have provided software architectures. The software features, of course, we can do the memory composability. You want to allocate different memory modules to different hosts. Then we can configure as each port as the device port or become host port. Here, I don't say there is a, in fact, there will also, the most important is memory sharing among hosts. But as I just mentioned, that we don't care about the write lock. We just let memory verge to manage it. But we can create a whole mappings of the, we call it global memory address space in our chassis. We give a global memory address space, physical memory, to mapping DLUT tables to different hosts. to see the same physical memory. So it means that they can share among different hosts. You can share among 2 hosts or as many hosts as you want. But of course, it's being connected to the same switch. And then we can also configure the host memory address, because when you ask the host, say, hey, please reserve like from your 2 tera to 4 teras memory space for us. And then you probably can say, hey, I want to reserve even more or smaller. Then you can choose how big size that you want to reserve from host memory space. And we collect all the performance data and we store it for like at least 32 hours for you to see what's average performance being used and how you want to use it, that data to do some analysis for your application, or for you to choose which memory that you think is the best fit for your memory allocations. Okay. So this is a Redfish API structured service that we provide in this one. In the root service, you have 3 different services. Now we provide all the Fabric services. In the Fabric, CXL, and all the others like return like CXL's port configurations, memory mappings, or their ingress egress kind of number that we will provide from here. This is a GUI. I use a GUI because it's more visual and you can imagine what feature that we provide. So when you click host 1, you see on the top of the bar, you see there is a base address from 8 terabytes to 9 terabytes. He reserved from this host 1 terabyte memory address. And then you see there's a MD09, 512 gig. It's coming from MD09. It's on here. Then you will see the MD09 coming from which memory modules. So you will see there's a host memory address being occupied by which memory descriptor from which memory modules. And then on here that you see all the memory descriptor list is being created, and data binding host. And this is the MD memory descriptor belong to this host 1. So it's give you a clear view that from host point of view to see the whole memory descriptor is being created and belong to it. Of course, we have another, but I do not show it. It's from the device point of view. You also can see the other way around to see this device has been created, how many memory descriptor, and which memory descriptor been assigned or mapping allocated to any host. So you can see it, and you can see the shared memory from which memory descriptors. We currently working with Open Fabric Management Framework. So we put 1 agent, 6 agents in it to provide all the information that we have from our API, and can let the OFNF framework orchestration to query the same information from our systems. So we have a few different solutions that we can use 2 DINs per channel, because our partners have to make it 6 memories modules with 4 DIN per channel or 2 DIN per channel. So you can combine with different DIN and to create what you want. Currently, the biggest one in this version is a 7 tera, a single box, the biggest one. Okay, then you have a smaller one if you use a 2 DIN per channels. Okay, so I know that you have lots of questions want to ask about the latency, about the schedule, about the portfolio. We are working on the very first one, so we just bring up everything to online. So I think on the freshman summit you will see all our data what becomes out. But not now, because now we have we already let the switch can see the memory and can to allocate to the memory, but you know that they're not finished. You need to let a 1.1 host to screen the 6 memory behind the 6 switch. So that is a bit challenging, a little bit tricky. So we work with Intel, we work with the Samsung to try to make sure the B-Dave could be read from the host point of view. So that part is we are working on. So I think it's we probably need another 4 or 5 weeks we can get it ready. And at that, by then we will have, and then we will have some of the real data, latency, bandwidth, and all the testing system, production systems that will be available to all the peoples. So I think the very first thing that we will make it ready is to remote data memory verge, to access it, to feel it, see, hey, this is right, this is not right. So we will then can provide to the access to lots of partners and the customers.